So, we've got our repository projects and we've got our window library projects. We've not yet got anything to build and run. We've got it to build but not to run. And even after this exercise we won't have anything to run because we're going to create libraries. Object libraries and executable libraries. Those are the two basic types of libraries that we provide. Object libraries basically contain a collection of Synergy source files that once compiled into object form are put into the library. So your subroutines, functions and class-based logic all get compiled and put into the individual units inside the object library. Object libraries are then used when building other libraries and mainline programs. And when built against the object library, all the instructions for each of the methods and classes are all taken and put into the resulting target mainline or library. So, any routines used within mainline programs, for example, will become part of the resulting mainline executable runtime unit, which often makes these quite large. And it also means that if you need to change something, you change it in your source code, you rebuild your object library, you then have to rebuild and relink all the mainline programs. And then distribute all the mainline programs. Object libraries are really not the way forward. They are still a requirement. There is a limit to the size of an executable library. So if you exceed that limit, and you can exceed that limit if you use the .NET API, for example, then you have to fall back to an object library. Executable libraries can only be a certain size. But in essence, executable libraries are the way forward, as I'm sure you all use executable libraries. They're basically the same as an object library. They contain a collection of Synergy files, the compiled files, and those in turn contain your subroutines, your functions, and your class-based logic, just like the object libraries. But the primary difference, obviously, is the executable library. When you link against an executable library, it links a reference to the routines within your executable library and not the routines themselves. So the mainline program is a lot smaller because all it contains is a reference to the routines inside the LB. Change the routines inside the LB, and the mainline program picks up the modified, changed, updated routines in the LB. You don't have to relink the mainline, you don't have to redistribute the mainline. So that not only makes the resulting target mainline program, for example, significantly smaller in size, but also means you can update the executable library without actually rebuilding and redistributing your entire application mainline programs, if you have multiple mainline programs. As I said, executables have always been the real solution to deploying componentized solutions and software to your end users. And yes, the de facto standard. So why are we discussing object libraries? Well, primarily, when you build an object library, the build process is quite clever in that it understands that you've changed one routine, that routine will get built, and not all the routines. That one routine will be put into the object library because you can put individual routines into an object library, and life is good. So if the library's got several routines or several hundred routines, you don't want to rebuild them all if you've only changed one. Each routine built, as I say, individually and added to the object library. Object libraries, as I say, allow the insertion, the replacement, and the deletion of compiled units from within those libraries. So again, if you only change a single source file, it's just that single source file that gets put into the object library. And that's all handled under the hood. You don't need to worry about any of that stuff. So building object libraries can actually be very efficient. Executable libraries are a little bit different. Executable libraries, basically, you're going to be building everything, or when this slide was created, you would build everything because the executable library has to be recreated every single time. You can't put an individual routine into an executable library. All the routines have to be put into the executable library. Now, it does mean that can be a little bit slower, but now, originally, it used to build all the individual routines and then put all the individual routines into the executable library. Now it's a bit clever inside Visual Studio, and it will only build the routines that you've changed before putting all of those routines into the ELB. So it basically keeps the individual object files hanging around. In the olden days, though, that could be a lot slower if you had to rebuild the entire, all the code every time to rebuild the ELB, which is why you created the OLB, and then you can inject the OLB into the LB. So that means you build one file in the OLB, you put one file into the object library, and then the object library is used as the source to inject into the executable library, thus making the creation of the executable library a lot quicker. And we're all about high speed in this day and age. So, note a moment ago I said you can create an LB from any input source. The input source can be the source code or it can be an object library. So the input source doesn't have to be a collection of compilable units inside your project. You can put source file in your executable library project, and many people do. But also you can put them into your object library and then use your object library as the input source for your executable library. So, notice the reference source, and you'll see this in your project when you create it in the workshop. Here we're referencing the object library inside our executable library, called Executable Library 2. Yours will be named a little bit more appropriately, I hope. And this is going to define the input source. All the compiled units inside that object library will be put into the resulting executable library. And obviously we're using Visual Studio and MS Build and all that fancy stuff. So the build system fully understands that if you reference something and that something changes, so we make a change inside the object library which causes the object library to rebuild, that means this project will need rebuilding and the build system will do that for us. So it'll take the contents of the object library and create the executable library from it, all very fast and super and quick. Nothing gets built inside this project. We've no source files inside the executable project. It purely is an injection from the object library to the resulting executable libraries. And doing this, prior to some of the recent changes, we did find some real performance gains at a lot of places using object libraries injecting into ELBs. Notice also here that although we're injecting our object library to create the executable library, we're not limited to that. We can also add source files into the executable library, and we can have multiple object libraries into an executable library. So it's very configurable how you create these executable libraries. Just remember that an executable library does have a size limit. So to build your libraries is going to be very, very simple. We'll give you the code files and you can add them to the project. But that would be sort of too simple to just do that and does not reflect the issues that you're going to get if you do and when you do, or if you have done this back at the ranch. So let's take a look at some of the common issues that you're going to or may encounter. And yes, the code we give you will have these issues. So we're not going to give you something that just builds straight out of the box. You'll need to fix these issues before you can complete the building of your object and executable libraries. First, we need to reference the repository. Otherwise, the code won't know where to find its structures from, because remember, we're not doing include files anymore, we're including directly from the repository. Now, before Visual Studio, you would create environment variables RPS mfill and RPS tfill and point these to your repository, and you set those up in a Workbench project or in your Synergy.ini or on your Syn user or at the command line or at a batch script. In Visual Studio, we don't do that anymore. Anyway, for your primary repository, that doesn't mean that you can't have multiple repositories and still use RPS mfill and RPS tfill in different ways to reference different repositories. You can do that. But by default, if you have a single repository, you don't set RPS mfill and RPS tfill. You literally connect to and reference the repository project. And under the hood, the build system that we provide sets RPS mfill and RPS tfill for you, okay? Simply by adding that reference. And you can reference the repository from any Synergy project. So you can reference it from a Synergy traditional project and a Synergy.NET project, as you will see in later life. You can reference, as I said, additional repositories, and you can use something we call common properties for doing that. And we'll talk a little bit about common properties in a moment. When you bring in the code, you're most likely going to have include files as well as repositories. Not the data definitions, but include files for .defines and all that kind of stuff. And Visual Studio obviously needs to know where they are. Again, you could put them in the command line, batch file and run Visual Studio from that, or Synergy.ini, etc. We don't recommend any of those. Visual Studio environment needs to know where these include files will be, and you're going to set logicals to enable them. The most appropriate place is common properties. And that's where we can create environment variables that are common across all the projects within Visual Studio. Now, there is a checkbox in there that says use common properties. You need to check that, although by not checking it, the projects will actually see them. So it's a bit strange, but we do need to set that. You can define project-specific environments, and to do that you would use the Environment Variables tab, not the Common Properties tab, which is the one above. But a word of caution, don't rely on the fact that these will take precedence over common properties, because it's not always the case. And we suggest and would recommend that you don't use that and just plug everything into common properties. If you need to make some code changes to be able to use the common properties like that, then you may need to make some code changes. For example, create additional common properties and additional environment variables that are, for example, named for a particular project. Now you'll notice in this screenshot in the properties list, there's a drill button. The drill button, if you click it, brings up a Windows File Explorer and allows you to locate files on your folder. I strongly recommend you don't use that button and specify folders, because it will hardwire the folder to the path that you're in and all that kind of stuff. And if you've got a multi-developer environment, it could cause problems if people put things in different folders. So as you use environment variables, and you can see in our example, we're using the MS Build variable $solution_dir, and that says, right, this is my root folder. From that, you can use hard paths, because the hard paths will be named your project names and be named bin.debug, etc. But it's where the actual root folder is. Don't use a hard C:\my development area, because when the next developer comes along, he might be on D:\. This is a better place to put my development area /. So stick to using things like $solution_dir. Now at this point, when we get to this point and you've set all those common properties up and linked against the reference the repository, the whole solution should build cleanly for you. But that's our object library, and that means if we link this to our mainline programs, the resulting programs are going to contain all those source files, or the code, the executable code from those source files, and we really don't want that. The resultant executable will be very large, and we don't get the freedom and the capabilities of what ELBs give us. So we're going to create an ELB from the OLB. And this gives us the best of both worlds. We can have multiple OLB projects all funneling into one ELB. We can have objects and source code funneling into the ELB as well. The object library is where your source code resides. That's where you'll edit the code, and that's where you'll do all the development, but the executable will build and be building an awful lot quicker. Synergy language integration inside Visual Studio, as you would expect, provides a project template for creating executable libraries. Once we create and select an executable library project, it will create one for us. By default, it adds code in a file called routine.dbl, and we're going to delete that, and the chances are you'll delete it every single time. The reason we put it in there is because templates, by definition, really have to be able to build as soon as you've created them. So you cannot create an ELB with no code in it. It has to have at least one routine, so we always create a dummy routine.dbl. It seems a bit superfluous and a bit strange to have to just then delete it, but there is method behind the madness. And then when we're to tell it where we want our code to come from, we simply reference our object library, so on-file object library. Once we do that, that's going to be pretty much it. Our executable library will then build and create an ELB. However, and there is one difference between Visual Studio and the way that you've been building. And I have talked about this in previous sessions, in previous years. The way things build in Visual Studio for ELBs is a little bit different, in that in previous years you define a logical and say, on the link command you would say logical : ELB name. And it's that logical that the runtime will use when it wants to find that ELB. Okay? We do it a little bit different inside Visual Studio, and you actually specify the logical in the ELB project, not in the resulting, this is where my main line should find the ELB project. Okay? So it's a little bit different. Does the same thing, achieves the same goal, but it's in a different place. You're defining it, you're saying, here's my ELB, and anything that uses it should use this logical. Where before it was, I'm building a mainline program and find this ELB using this logical. So it is a little bit different. On the Build tab, part of the project properties, as you can see at the bottom, there's the output path. And this is where you say, this is where I want my ELB to be created. But not only that, anything that links against it should use the logical that is defined at this point, not at the building of the mainline program. Use the logical, and that logical must exist and must be known to Visual Studio. So create the logical in your common properties page, and then you can use it in your ELB, and it will also then be available when you build main lines. Okay? So the sort of logical step is component properties, set the logical, define the logical, then go into your executable and define the output path as that logical. And remember the colon at the end. You will need that colon. Some things won't build straight away because things like the ELBs quite often now want to be completely self-referencing. So they want to understand, for prototyping purposes, everything that the code uses. Okay? So it's a little bit different. We're not building the main line here, we're building the executable library. And normally you'd see these, I need to reference other libraries at linking the main line. But in this instance, in Visual Studio, because we've got enable unresolved reference checking set, which is the default, it actually needs to know where other routines that are outside of the LB live. So as long as that enable unresolved referencing is set, you need to tell it where those other routines are. And we can fix this, and you will be able to fix this in the workshop. We ship the toolkit library, and you can add a reference to it. And the workshop will walk you through simply creating the reference. So it's your turn again. I've had enough. I'm done. Exercise 3 is going to be relatively simple. You're going to walk through adding an object library, adding code that you'll download from the web server. Then, once that's built and you've added the references to repositories and things, you'll then build a executable library, and you'll suck in the object library into the executable library.